Hello and welcome back to another YouTube video, and we're gonna solve a LeetCode problem, an easy problem which is called palindrome number. What's palindrome? Palindrome is when we read something backward as forward. But we're now talking about number specific, so every time I'm saying palindrome, I mean the number. So for example, if we're reading 1 to 1, the palindrome of 1 to 1 is 1 to 1, so this is a correct palindrome. But if we were reading 1 to 3, the reverse of it is 3 to 1, which isn't a real palindrome, so basically that's false. So we should write a function to implement this logic. So let's see. Every time we're talking about number, I usually like to start with three starting cases in which we relate to number negative values, positive values, and 0. Let's try with the negative value. If we're gonna read the negative value like negative 5, the reverse of negative 5 is 5 and then negative, and that's really not a correct number, so basically that's wrong. Let's try a bigger number like negative 603, which will result in 306 and negative at the end, which is also not a correct number. So basically any number that is negative result in a false palindrome because there is no palindrome with negative values. Now let's speak about 0. 0 is one single digit, like one digit, so any reverse of a single digit will be the same as any single digit. 0 is the reverse of 0 is 0, 1, 1, 2, 2, etc. up till 9. But when we reach to 10, then we find out, no, we need to see what's the problem, because for example 10, the reverse of it is 0 and 1, which isn't a palindrome. So basically we have like an edge cases. If it's negative, then we know it's already gonna be false, and if it's from 0 to 9, then we know also it's gonna be true. That's it for probably the negative values, and let's try the second digits and get into more details. Let's see, how can we solve this problem? First solution you think of is using a string, which is really not a bad idea. Actually, it's a nice idea, but we will have some overhead. There is always this built-in function where you can convert a number to string, but that takes resources. So there is another efficient solution which we can use using mathematical equation, and I'm gonna show you this solution and the string solution, where we gonna compare between them. The only thing that really matter in the difference is the overhead of so first solution is the string one, where we convert this number to a string using the built-in function. For example, I'm gonna use Java, which called value. It will convert this number to a string, and then when we convert it, we're gonna loop backward from the last character up till the first character. So the first element we're gonna loop is 3, and then we add it to our palindrome string, which we're gonna check at the end of our function to determine if the final result of palindrome is the same as the original value and not, and then we're looping backward and until we finish this loop, and that's it. That's for the string array. The time complexity for this solution will probably will be O of n, where n is the number of characters available in the string which we have converted from the number, and also there will be no, that's it for the time complexity. Speaking of space, there will be O of 1. We're not gonna use like any variable except for example 2, which is a palindrome string, and yeah, like what I'm saying was we're gonna use a variable for storing the palindrome, and we're comparing it at the end, and that's it. So there is no space complexity awareness for this algorithm, but there is another solution which I believe is better because we won't deal with the overhead of converting this number to string, but using some mathematical equations. So the algorithm is a bit simple. I don't know if you find it simple or not, but I'm gonna explain it to you and you will find out and judge yourself. First of all, we're going to determine the last digit available in our number, which is, for example, 3. How can we do this? Using the module operator, which will result in the last element in this number, which will be as 3. And we will find out the remaining of this last digit of the original number, which is 12, after taking the remainder by dividing it by 10, which will become 12. And we're now gonna seize the palindrome. The palindrome, to calculate it, we're gonna use the first iteration. We're probably we'll start with 0, and then we scale it up by the result of the previous palindrome. So first iteration will be 0 by times 10, multiplied by 10, and then we add the last digit we have calculated at that iteration. That's it for the first iteration. So the second iteration, we have got the remaining. We need the module of that remaining and to find the remainder of which will become 2. And we, after getting the remainder, we need to find the remaining of the 12, which will be 1. We're now gonna calculate the palindrome, which will be taken from the previous palindrome, which will be 3, and we multiply it by 10 because that's second iteration, and that means second digit. And then we will, after making it multi-digits, we add the last digit from that we calculated at the iteration, which will result in the second palindrome. We're coming for the third iteration, which will be the last iteration, as there is no more digits available for it. We're gonna take the remainder, which is 1. We're gonna check for the remaining number, and we find it there is no remaining number. And then the palindrome is the last previous palindrome, which is 32. We multiply it by 10, and then we add the last digit available we calculated at that iteration, which will result in 321, which is the same as the original number 123. And that's it for the algorithm. The time complexity for this algorithm will be often, and we're not converting any number to any string, and there is no overhead. And the space complexity for this is of 1. We're using just 2 variables, one for the iteration and the other one for the palindrome string, palindrome number, I mean, not string. We're not using string in this case. This one is the second example I have. You can loop it through by yourself if you want. It's the same algorithm as the previous one. That's it for the conceptual view. Let's get